Hello, this is our manufacturing design project. We focused on the manufacturing principle known as machining, using a CNC mill to make and manufacture a Turner's cube. This required eye protection as well as supervision by a College of Engineering machinist. We used this sharp CNC mill to manufacture our cube. Currently, the machinist is showing us a method of how to find and coordinate the location of this block that we have found, that we decided to use. It works by wiggling this tool that is spinning while connected to the mill, and the closer it gets to the cube, once it touches it, stops moving and then kicks back a little bit when we overdo it. And then we record application. This must be done before machining, of course, so that the computer knows where to go. Now we get to the machining itself. Currently, we are using a particular drill bit that is long enough to where we can use a certain method the machinist suggested, where we directly cut the cube rather than turning over every so amount of times. Because as we've seen with previous videos, this method is not always feasible for other mills, as the drills are not long enough. So we had to decrease size from 3 by 3 by 3 to 2 by 2. And I don't know if you could see there, but there was a little effect going on where the drill was cutting off too much. This bit was cutting off a bit too much, and that caused the bit to be pulled down by the material. And this can be very troublesome, as it can cause damage to both the material and the tool itself. So the machinist suggested, as well as directed us, to make each pass of this bit a bit smaller. It is also suggested by the machinist that we cut the cube firstly at 2.1 by 2.1 by 2.1 inches, so that we have that 0.1 inches to do surface finishing to make it look prettier. And as you can see, the machinist was just adjusting the coolant nozzle so that it was more directly towards the contact between the mill, the drill bit, and the material. This prevents hardening as well as overheating of the material. And as we learned in manufacturing, most of the heat goes to the chippings. Days after, we started drilling the holes side by side. And more or less from the pulling down of the tool last time, we had to change bits, as the bit last time started dulling out as well as wearing out. This can be chalked up to it being pulled down previously, but also just overusage over time. This drill bit, however, did the trick in making the hole. And as the bit got more and more closer to the center, more passes were applied. This is because as we get towards the center of the cube, of the turner's cube, material becomes thinner and thinner. So we have to be more precise so that we do not damage the material. The end result required a bit of filing because the edges were severely sharp and could be damaging to one's hand. But in the end, this is our turner's cube. Thank you for watching.